So what we're going to try to do is get an overall tour of the head electronics and all the CCD electronics, pointing out all of the major subsystems, hopefully, and maybe saying a little bit about each one. At all three sites, we have in the computer room an isolation transformer, and I just have one sitting on the bottom of the cart down here. Which does two things really. It provides very good isolation and cleaner power for the HE, and also as it's used right here, it steps the voltage up from 110 volts nominal to 220 volts so that everything up here can be operating as it would operate in the field. That power comes in on a CPC connector through a custom cable that we bought, which is shielded, so that lets you get all the power all the way from the computer room to the HE, and you take good care of it. It is 220 volt coming in. For many people in the 220 volt world, it'll seem a little strange because if you measure, there are two hots that are 180 degrees out of phase, and it's only the voltage between those two hots that's 220 volts. And I did that so that we can use a shielded cable, and the leakage currents through the shield are very low because you've got one going up and one going down at the same time, and then they go back and forth like this. The net result is 220 volts top to bottom, but the shield only sees the leakage current from the difference between those two voltages, which is nominally zero, so there's very little leakage current through the shield. Otherwise, with all the capacity that you have between a single hot conductor and the shield, you'd have quite a bit of leakage current there, and it's just inelegant, to say the least, to have that. So that's how power gets into the HE. There is no power switch on the HE. So if you need to turn the HE off, you either have to disconnect this connector, which I do from time to time. It's kind of poor form because you always produce a little arc on those poor gold contacts. Or you can give the command to the APC strip in the computer rack. Normally it's on outlet number 4. Or there is a switch on the rack that contains the isolation transformer, and you can always shut it off with that too. So okay, so AC voltage comes in, and then you're going to want to slide around here, and there is a printed circuit board which is buried well inside here called the AC distribution board, and it is just a bus that has the 220 volt power on it. It also has provision so that you can power everything from 110 volts, but we won't go into that for the time being. All of the AC loads plug into that AC distribution board with these green connectors, which are quite reliable and work really well. They do have the characteristic that if you see there are slots between each one of the pins, and you can plug them in wrong. Don't do that. Make sure that they are properly registered up and down when you plug one in. And I'll show you how you plug them in wrong in another application here in a minute. It's a little difficult with them buried in here. So what you see is this whole row of 4-pin connectors where you have neutral, hot, ground, and the other hot available, and then there's one special one which gets the power in on 5 pins. I forget which one that is. It's one of these. And there's actually, looks like still have 2 spares. So if we grow something else, we can add things without making changes. The other thing is on that board are MOVs. How come I don't see the MOVs, Dan? Oh, they must be on the back. On the back. MOVs to protect for transients, and there's lots of redundancy there. They don't have an infinite lifetime, so we'd like to have protection no matter what. So what are all these things that are plugged into the AC distribution board? Most of them are connections to the power transformers. So for instance, this is transformer number 7, T7. It is for the plus minus 15 supply. And there is one of these for each of the power transformers. And I don't remember how many there are, but there are a lot. And they are all located, mounted on this plate. And you can see 1, 2, 3 of them here. And you can see other ones over on the other side if you were to go over there and look. And I think there are 9 altogether now. Different voltages, different power levels to provide the different voltages required in the HE. The output of those transformers, the input, each one of them has 2 primaries. Both primaries are 110 volt nominal primaries, and you can either hook them in parallel and you can then use them on 110 volts. We rarely do that, but you can also put them in series and use them on 220 volts, and that's the way they're normally used. The secondaries are all different depending on what power you need, what voltage you need, and all those secondaries come up to this bank of bridge rectifiers. So they take the AC voltage from the transformer and turns it into unfiltered DC, let's say. And you can see there are many connections on them, and some of the transformers, the secondaries, there are 2 secondaries in parallel. Some cases there are 2 secondaries in series. You can refer to the sheet in the first section in the black book, and you can actually see all of this drawn up quite nicely now. The output from the bridge rectifiers comes through these cables, 1, 2, 3, 4, 5, to more green plugs. And that carries the unfiltered DC to the capacitor board. And all of the DC filtering is done on the capacitor board. That is for the science and guide array, at least all of it's done here. And the reason for that is then you have all of the AC currents circulating on this wiring, and none of it goes any farther upstream into the box, and it gets rid of all of the AC currents from the line frequency quite nicely. And as promised, I can show you that there's one of the green plugs. That one's for one of the voltages for the utility board, probably the 5 volt for the utility board. And you see it is quite easy to plug it in like that, which is wrong. Now in that particular case, there are only 2 pins, and so you'd get no voltage because you don't have a circuit with just one, with just 2 pins. But you could also take this one and plug it in, offset by 1, and that would be, I don't know what you'd get, but it might not be very good at all. So you want to, whenever you're plugging in these green connectors, you do want to make sure that you get them registered correctly. So my recommendation would be do it carefully and then check that you're happy with the way it's done. Okay, so that's getting from the bridge rectifiers to the capacitor board. And the capacitor board, you can guess by its name, it has the capacitors on it. It also has grown now fuses. So each one of these supplies has a fuse. It also has bleeder resistors, so that when you turn the power off, these capacitors, there's a lot of capacity here, and they're discharged through those resistors so that in a reasonable length of time, the voltage has gone to 0. Again, if it's something critical, you're plugging in a board or something and you're not sure of the state, you should check that the voltage has actually gone low enough that you're willing to plug something in. The other thing that's on this board are divider resistors. So all of these raw voltages are divided down to a level that can be read by an ADC, an analog to digital converter, on the utility board, and that's how we read back those voltages. Okay, so then I think we want to swing around and look at the other side of the capacitor